mitigate climate crisis, the utilization of fossil energy has to be substituted by renewable energy sources as fast as possible. To this challenge, the project RENergetic responds with the concept of urban energy islands, based on the rationale that if every community generates the energy it needs more or less locally, the problem can be solved globally. Consequently, an urban energy island is a geographically delineated district that aims at achieving a high level of energy self-sufficiency while offering energy services to external grids when needed. RENergetic tackles this task by optimizing the generation and the composition of energy supply across the vectors electricity and heat, and by distributing this energy efficiently. On top of this, energy demand is adapted to available local supply as much as possible, building on the acceptance or even the active support of the inhabitants of the energy island. The pilot site at Poznan is organized by 3 entities: the Poznan University of Technology, PUT, the Poznan Supercomputing and Networking Center, PSNC, and the heat grid operator VEOLIA. In essence, for heating the university PUT, the pilot focuses on optimizing both heat supply and demand by cross-optimizing the 2 energy vectors heat and electricity. In the original infrastructure setup, the university regularly received its heat supply from the VEOLIA heat grid without any but the most generous capacity constraints. In an innovative approach, the RENergetic system will integrate this original setup with 2 additional heat sources. On the one hand, optimizing the usage of heat pumps at times of a high supply of local photovoltaic electricity, and on the other hand, integrating waste heat from the data center PSNC, which is done via simulation. In the case of PSNC, this means that the potential heat supply from the data center needs to be forecasted using a multi-level data center energy model in order to assess multiple scenarios of waste heat reuse and to so prepare strategic decisions about the development of energy island infrastructure. These decisions will lead to a reduced heat supply from the heat grid operator VEOLIA, thus saving not only CO2 emissions, but also significantly cutting cost. This also entails the creation of novel business models together with VEOLIA, and in the end, this will lead to a significant increase of the level of self-sufficiency of the PUT energy island. Additionally, the collaboration with students is sought for to amend the supply-side optimization with a management of heat demand that capitalizes on the heat storage functions of buildings. In times of rare events of high heat demand that coincides with extra demand for CO2-intense heat supply, students will be asked to temporarily accept a reduction of the temperature in the heating system. To reward students for cooperation, the RENergetic physical meeting hub will be collectively erected in a combination with a students' party. The Poznan pilot is thus testing the RENergetic modules for social campaigning, for the multi-objective multi-vector optimizing, for heat demand response, and for local waste heat simulations.